Number 5 has a physical context. We're tossing a ball straight up in the air, and we're given the equation that represents that model of tossing the ball up in the air and letting time run. And then we're asked, how long will it take for the ball to reach a height of 100 feet? So we know we need to set the height equal to 100. That's S. So we've got our equation. It's a quadratic equation. We can simplify it by dividing everything by 4. That will just make the numbers a little smaller. So it's always nice to check and see if there's a common factor that you can divide by to make the numbers a little easier. Once I've done that, I'll just move everything over to one side and continue with this algorithm that we have. So simplify it, move everything over to one side, and then the next step will be to divide by the number in front of t squared. I do that in 2 steps here. You can do that in 1 step. The reason I did that in 2 steps here is because I saw that there's a common factor of 2 in all of those terms. So I wanted to simplify it a little bit and make the numbers a little smaller. And then from there, I would divide by the coefficient of t squared. So I'm going to divide by 2 again. Once I divide by 2 again, the coefficient of t, that middle term, will be a fraction now. So b will be equal to that fraction, negative 25 over 2. So when I look for my average, I need to divide that by 2. I take negative b and divide it by 2. So just as a reminder, when b is a fraction and you want to divide it by 2, you multiply it by 1/2. So we get 25 over 4 for the average. Now for our equation, we're supposed to square the average. So we're supposed to do 25 over 4 times itself. So I will carry that multiplication out by hand off to the side. And this is the type of thing that I expect you to be able to do by hand if you need to. I don't want to give you a whole bunch of calculations to do on an exam, long calculations. I don't have any need to see you do lots of arithmetic, but I do want you to be comfortable with doing a little bit of it. So I will try not to give you very complicated numbers to work with, but if I do happen to give you something a little complicated, I do want you to be able to work with it. All right, so we got our equation. We want to solve for z squared, so we add it to both sides, subtract 6. And now I want to combine fractions, so I need to turn 6 into 16ths. So I'll write it as 6 over 1, multiplied by 16 over 16. And then off to the side, I'm multiplying 16 times 6, and I get 96. So 625 16ths minus 96 16ths, which means I need to subtract those two numerators, 625 minus 96. So I'll do that off to the side as well. Sorry you can't see everything that I'm doing off to the side. I will try to do better with that in future videos. I know it was like that in my last set of homework videos as well. I'll try to do better. All right, once we've subtracted, then we just need to take the square root of both sides. I know the square root of 16 is 4. So I'm going to go ahead and simplify that to 4 in the bottom. The square root of 529 I'm unsure about. And if I had lots of time, I would be able to figure it out, and I would expect that you could figure it out as well. But I don't plan to give you a number that large and expect you to simplify it. So you could just write your answer with that square root of 529 in there. And it turns out that the square root of 529 is 23. So we could simplify these solutions a little bit. And make them look nicer. We're asked to find how much time it takes for the ball to reach 100 feet. So if you think about these two time values, the smaller one is the one that we need, because the ball is going to go, it's going to go up and hit 100 feet and keep going up and then come back down and hit 100 feet again. That's why we have two different solutions. We want the smaller one, so we'll take the subtraction version instead of the addition.